Just wanted to start off with a shout out to Love, to TreePeople, to Rich, to Eugene. Um, we often don't mention such emotional things in our presentations. We tend to be super pragmatic and academic, but we are people who are super compassionate and who clearly love the earth, our communities, and we want to make sure humans are around for at least a few more hundred years, but if we restore the soil, a lot longer. So after following Kristen and Sally, I'll probably be a little repetitive, but I'll skip over things that they may have already covered. My background is primarily ecology, and I approach soil conservation from the lens that preserving soil, conserving soil, enhancing soil is biodiversity conservation and restoration work. So I also work in agriculture because I see agriculture as kind of that perfect silver bullet to addressing a lot of societal issues as well as environmental and ecological. Once again, someone mentioned earlier, Artema, I think, preaching to the choir. We manage soils to essentially enhance the nutritional value and the yield of our food. Sally was talking about her 16-inch plus carrots, sequester carbon dioxide in the soil, reduce and address climate change, and support biodiversity. So as species go extinct or become endangered, a huge component of that is the soil's ability to remove toxins from the environment, as well as support life from microbes to insects to larger fauna. Healthy soil can be the foundation of a biodiverse and species-rich environment. So urban soils, although, as Sally mentioned, aren't always terrible, they can be. And of course, in older cities, there's potentially decades, if not centuries worth of damage that is inflicted on humans, essentially moving heavy machines around and spilling and intentionally dumping chemicals and man-made things. This photo on the right is an image of debris we pulled out of the ground at the Michigan State University Detroit Partnership site about 2 or 3 years ago. It's about a 3.5 acre former public school property that I'm developing into an urban ag center in Detroit. And pretty much anytime we dig, whether it's a couple of inches or a couple feet, we usually find anything from rebar, PVC pipe, tubes, wiring, glass, asphalt, concrete, you name it. It's probably somehow found its way intentionally or unintentionally into the soil. But there are some sweet spots, some really nice spots on the site, really sandy, pure sand, maybe clay loam areas as well, which are always a treat when we come across those. Given the soil at the site and kind of my capacity for research and the earlier portions of my job, I designed this relatively small soil project. Pictured in here is a 4 by 9 plot, which has 5 by 10 foot kind of micro plots going from left to right. These first 3 rows are no-till plots. The next 3 rows were plots tilled with a rototiller. And then the last 3, there's actually one, I missed the no-till, which is outside. The last 3 were tilled with a tractor. And one of the things that just this picture alone can tell you is that it looks like everything going on in the no-till plots is much greener, much more lush, and that's both on the weed side and the vegetable side. But it's a testament to some degree to how minimizing soil disturbance can be beneficial for plant growth. The last 2 years, we simply grew cover crop mixes, which are listed here in this table on the bottom left. And those plots, those 3 different soil groups, high disturbance, minimal disturbance, no-till. And then pictured over here are the tools we used. So with the tractor, we were using a subsoiler, a moldboard plow, and a rototiller. On the no-till or the rototill plots, we were using a rototiller implement attached to a two-wheel tractor, and we simply broad forked the no-till plots and put 2 inches of compost on all of those plots as well. So I don't want to get too into detail, so I'm just showing one graph from the results of our first year of that experiment. And of course, not surprisingly, this graph is showing compaction depth in inches. The null is plots where we did not plant any new vegetation. So whatever was in the soil seed bank came back. Comp was the cover crop mix that addressed compaction. Puri was a cover crop mix that had more perennial plants in it, primarily clover and hairy vetch. And then weed suppression, WD, SP, were cover crops selected that grow very vigorously and tend to outcompete weeds. So essentially, the tractor till group, the roto-till group, and the no-till group, it shows the variation in compaction depth. And some of the no-till plots, you could get down relatively deep with a penetrometer, pictured in the top right here. But overall, not surprisingly, disturbing the soil very heavily with a tractor and all the tools that you can attach to a tractor increase the depth more so than a rototiller or no-till. But at our particular site, and I simply wanted to kind of highlight just on our site, which is 3.5 acres out of a city that's 149 square miles, there's so much variability. And I forgot to set a timer, but I'll keep an eye on the clock. There's so much variability that it's almost difficult to kind of come up with best management practices overall, and you generally have to be really specific. So based on the research, I tend to encourage folks to, like Sally said, amend soil a lot. And I'm a huge proponent of biological inputs versus chemical inputs. So mycorrhizae, rhizobium, blood meal, beneficial nematodes, beneficial insects, worms, compost teas, kind of anything you can think of that can add organic matter naturally to the soil and increase soil metabolism is going to do more work both in the long term and to some degree in the short term, depending on the quantity that you add, will improve soil much faster than essentially stirring it up multiple times a year, once a year. And depending on what kinds of plants you're growing in the soil also should inform how you manage soil for crop production. Most urban farmers and farmers in general tend to function within the paradigm of annual crop production, and a lot of those annual crops only need the top 4 to 6 inches to grow well. So that kind of depletes to some degree the need for really deep soil work, unless you have compaction issues and water infiltration issues. But overall, if you just want plants to grow in one growing season, if you amend those top couple of inches with organic matter, then you can generally resolve a lot of problems. And you also don't stir up when soil is contaminated or laden with debris like ours is. You kind of eliminate the entire need of having to remove or deal with all of the contamination and issues below ground when you simply build good quality soil on top. I did want to speak briefly about biochar. The first bullet point, the new frontier or the red herring. There's certainly a lot of businesses, corporations getting into biochar production. I certainly believe that there are many uses for it. So far, in the research we've been doing at the MSU site in Detroit, it hasn't seemed, whether it's activated or simply applied to soil or incorporated into soil, to make a big difference in plant yields. And this year we grew tomatoes, basil, garlic, shallots, black eyed peas, okra, and corn in different biochar mixes and in those different tillage groups that I mentioned earlier. And we haven't done all of the analyses yet, but it doesn't look like there will be a significant difference between the crop yields based on whether biochar was present or not. However, biochar is certainly a valuable substance for, as this image shows on the right, improving soil tilth, creating microhabitats for beneficial fungi and bacteria, improving the soil's ability to hold on to nutrients and water, and to some degree building drought tolerance. So I wouldn't put, as folks tend to say, all your eggs in one basket, and I do think it's valuable to certainly play around with it depending on the scale. And then the other issue with biochar is where you're accessing it. So you don't want to be shipping cubic yards of biochar long distances, of course, and the production of it, if you're burning trees, living healthy trees, potentially for its production, that's also counterproductive. And there are a lot of biochar production systems that can utilize the energy produced from creating biochar for either creating electricity or heating a space or something like that. So making sure that the production and access of it is integrated and not kind of singular. The main thing that I wanted to talk about, and I think it's apropos or wonderful that TreePeople is hosting a soil symposium, is just the value of woody plants in the landscape, and edible woody plants in particular. This diagram is taken from the Facebook group Edible Cities, and it's essentially how I envision trying to transform urban settings, rural settings, suburban settings across the country and across the world, hopefully. And certainly there are places that already look like this. But by essentially maximizing woody, perennial fruit and nut crop production in our landscapes, on our streets and our yards and our parks, potentially cemeteries, managed public lands, we can really increase access to food, increase the soil's ability to absorb water, hold water, accumulate organic matter, accumulate carbon, by kind of moving away from that typical annual crop production, as well as simply mowing grass lawns. And of course, on the West Coast, that's a much bigger issue than on the East Coast. But one of the things I wanted to mention, as well as put in the chat, is Keep Growing Detroit. An organization in Detroit did a stormwater research project, and on an organically managed urban farm plot in Detroit, the scientists who were running the project were able to run an open fire hydrant on a vacant lot that was essentially a garden for 12 hours, and none of that water ran off into the street or into the stormwater system. And that was kind of a huge outlier or indicator that we can be managing urban land to hold a ton of stormwater. So they were doing these rainwater simulations and seeing how different types of land management had a capacity to hold that water. So also by integrating these deep rooted perennial plants, we're increasing the land's capacity as well as above ground capacity to hold water at our sites. And then beyond that, beyond the soil conversation, we're feeding people, you're creating kind of micro business, revenue streams, entrepreneurial opportunities, sequestering carbon, addressing climate change, and then edible landscapes, depending on the height of the trees, can also address the urban island heat effect and create habitat for birds and other fauna. And this is essentially a more detailed diagram of how edible landscapes can be designed. Essentially, you could have kind of 20-foot plus, 30-foot plus trees growing in the landscape with shorter, kind of 10 to 15-foot trees, have climbing plants, grapes, vining, vegetation growing on those things, and then also incorporate shrubs and edible herbs as guilds kind of around the base of those trees to help the trees both acquire nutrients and be able to get mutualism relationships with other plants around their root systems. And hopefully, I'm keeping it under time as well. I'll wrap with that. And in the bottom left is my email and our Instagram page if folks are interested in following us. Thank you, Rich.